My name is Brian Alanis, and I will attempt to explain glycolysis in 10 steps. We have step 1. We have hexokinase, which the first step in glycolysis is a conversion of D-glucose into glucose 6-phosphate. That enzyme that catalyzes this reaction is hexokinase. Next, in step 2, we have phosphoglucose isomerase. So the second reaction of glycolysis is a rearrangement of glucose 6-phosphate into fructose 6-phosphate by glucose phosphate isomerase. Next, we have phosphofructokinase, and with magnesium as a cofactor, this changes fructose 6-phosphate into fructose 1,6-biphosphate. Next, aldolase. The enzyme aldolase splits fructose 1,6-biphosphate into two sugars that are isomers of each other. These two sugars are dihydroxyacetone phosphate and glyceroldehyde 3-phosphate. Next, triose-phosphate isomerase. The enzyme rapidly interconverts the molecules dihydroxyacetone phosphate into glyceroldehyde 3-phosphate. Glyceroldehyde phosphate is removed. And next, we have glyceroldehyde 3-phosphate dehydrogenase, GAPDH for short, and dehydrogenates and adds an inorganic phosphate to glyceroldehyde 3-phosphate, producing 1,3-biphosphoglycerate. And phosphoglycerate kinase. Phosphoglycerate kinase transfers a phosphate group of 1,3-biphosphoglycerate to ADP to form ATP and 3-phosphoglycerate. And next, phosphoglycerate mutase. This enzyme relocates a P from 3-phosphoglycerate from the third carbon to the second carbon to form 2-phosphoglycerate. Then next we have NLS. This enzyme NLS removes a molecule of water from 2-phosphoglycerate to form phosphoenolpyruvic acid, PEP. And last, pyruvic kinase. The enzyme pyruvic kinase transfers a P from phosphoenolpyruvate, PEP, to ADP to form pyruvic acid, and ATP results.